This is still chapter 11, section 8, but we focus just on finding the area of an entire circle in our first part of the lesson. Now we're going to focus on the other part of chapter 11, section 8. That's finding the area of just part of a circle. Now, a part of a circle, the way they're wanting us to do it, is called a sector. So it's just part of the circle, but they call it a sector. Its area depends on the radius of the circle and the measure of the central angle, which is this part right here. Which, if you think about it, if I want a sector that's this big, that's obviously a much bigger angle there than it is right here. So the bigger the angle inside the sector, the bigger area we're going to have inside the sector. Whereas if I drew a very small angle, like right here, that and wasn't including this, just including this, that'd be a much smaller sector we were finding, smaller area. So the central angle is an angle with a vertex. That's where the two lines that form the angle meet. So that's the vertex right there. Just that single point. The point where the two lines meet is called the vertex. Now a sector is just a portion of the circle. So one way we can find the area of a sector is to set up a proportion. We already know how to find the area of a whole circle. And we know a whole circle, if we go all the way around, is 360 degrees. So they're wanting us to now find the area of the sector, of just part of the circle. And we're going to relate that to the measure of its central angle. So just to help you understand what they're doing here, when I have a whole circle, that goes 360 degrees all the way around. If I wanted to find out half the circle, then that would be 180 degrees, because that's a straight line. Well, 180 degrees is half 360, so that means the area of half the circle must be half the area of the whole circle. So the simpler way to use this, we just plug in the formulas. Area of a circle is pi r squared. 360 never changes. The area of the sector we're looking for, we'll just call A, because we're trying to find. And then the measure of the central angle, and that'll be provided in all the problems. It'll change from problem to problem, but it's provided. So let's look at this one right here. They want us to find the area of this shaded sector. So I have this is just a rewrite of the proportion. We plug in 5 for R. We're trying to solve for A, so we just leave it as A. And our central angle is this 90 degrees right here. So to solve a proportion, if you remember, we cross multiply. That means the diagonally we multiply. Then we have, 5 squared is 25. 25 times 90 is 2,250 pi. And you could plug that whole thing in if you want. But one thing, here, let me show what I did. So I chose not to multiply by the pi yet. So I just said, let's do 5 squared times the 90 and got 2250. Now the reason I did that is because you don't want to round your answer until it's the final answer. And if I typed in pi right now and got that crazy decimal here, I might change my final answer just a little bit because then I'm rounding too early. So I'm going to wait until this final step before I use the actual pi button. So now that we've cross multiplied, we want to get A by itself because our goal is to understand what is the area of that sector. So we'll divide both sides by 360. So 2250 times pi divided by 360. So we get that area to be 19.63. Oh, it said around the nearest tenth. Sorry, read the directions. Around the nearest tenth. So 19.6 square centimeters. Hey, good news. There's an even quicker way. This doesn't take too long. But I don't know if you remember when we did the percent proportion, that is over of equals percent over 100. One good reason to leave that one in proportion form is sometimes we were solving for is, sometimes we were solving for of. Let me just write it so you see what I'm saying. Sometimes we had to solve for is, sometimes we didn't know of, sometimes we didn't know the percent. So it changed all the time which one was the variable we didn't know. However, in this proportion, A is always what we're going to be trying to find. So it'd be a lot easier if we just got A by itself. So to do that, we just need to get rid of this n. So A is being divided by n. So let's multiply both sides by n. So that leaves A by itself. And since n is a number that we're going to be given in the formula, I'm just going to write that as n over 360. Because that's the number, that like it was 90 in this previous one. It's the measure of the central angle. So I'm just kind of putting the two numbers together in a fraction. So I've covered the n of 360 times pi r squared. So that's a simpler way and going to be a much quicker way for us to plug this in, because then we don't have to rearrange, cross multiply and all that. We just plug in the n, plug in the r, and compute it. So I've just got 3 examples for us to do here. So find the area of the shaded sector in the circle at the right. Round to the nearest tenth. So we use the new formula we just did, which is n over 360 times pi r squared. So the two pieces we need to add in are the n, the measure of the central angle, which is 120, and the radius, which in this case is 6. So I can type all this in the calculator. 120 over 360 times pi times 6 squared. So 120 divided by 360, because remember fraction is division, times pi times 6 squared. Then we round to the nearest tenth. So I see a 6 in the 10th spot, but that 9 tells me to round it up to a 7. So it's 37.7 square meters. Okay, I encourage you to pause and try number 2 on your own. Okay, we'll use the same process. Formula is n over 360 times pi r squared. The n is 235. And the radius is 7.1. And don't forget the squared like I just about did. We can plug it in just as we see it. 235 over 360 times pi times 7.1 squared. So rounding the nearest tenth, we see a 3, but since that 7 is 5 or bigger, we round it up to a 4. So it's 103.4 centimeters squared, or square centimeters. Last one. I'm going to draw a picture when they don't give me one. It's usually easier, but you don't have to. The diameter of a circle is 16 inches. It has a sector with a central angle of 75 degrees. Well, this doesn't have to be accurate, but like I know 90 degrees makes a right angle, so I'll just make it a little smaller than that. Say this is 75 degrees. So this is the area we're trying to find. Find the area of this sector to the nearest tenth. So here's what's tricky about this one. Look at our formula. A equals n over 360 times pi r squared. The two things we need to figure this out are the central angle, which we have that at 75 degrees. No equal sign there, pi. But we also need the radius. They didn't give us the radius, they gave us the diameter. So remember, if the diameter is 16 inches, to get the radius, we cut that in half and get 8 inches. So we plug in 8 for r. So don't don't forget to make sure you're plugging in the radius. This is true just with any area formula for the circle. We want the radius, not the diameter. So 75 over 360 times pi times 8 squared. And we round the nearest tenth, so there's an 8, but that 8 after it tells us to round it up to a 9. So it's 41.9 square inches.